For this video, we're going to be discussing function transformations. So back in geometry, you did transformations of shapes. You did rotations, reflections, dilations, and translations. We can do those same things, but to functions. So a function can be transformed by changing the equation of a parent function, right? And functions can be flipped, they can be stretched, or they can be moved or slid around. So we're going to talk about how that works in this video. So we've got this equation, f of x equals plus or minus a times, in parentheses, x minus h plus k. And these things all do something, right? This is the general form of an equation. And a, h, and k are all used to describe transformations. So is this plus or minus sign. Each one of these things does something different to the function. So let's talk about what they all do. Let's start with this plus or minus. All right, a negative coefficient is going to flip a function over the x-axis. Okay. The other thing we could say is that this is a vertical flip. All right. So you could see down here that it takes this quadratic function. Whoops. And if I have this is f of x equals x squared, the parent function. And if I put a negative on the front of it, all that does is it flips it upside down and makes it f of x equals negative x squared. And it flipped it vertically. All right, so that's all this plus or minus sign does. If it's negative, it flips the function. All right, let's take a look at that a. The leading coefficient a stretches the function. All right, it either makes it narrower or it makes it wider. And it depends on what a is. So this is f of x equals absolute value of x, the parent function. And if a, this leading coefficient, is bigger than 1, then it makes the function narrower. So I've got f of x equals 2 times the absolute value of x here. This 2 is larger than 1, and it makes my function narrower. If a is less than 1, then the function gets wider. So this is f of x equals 1/2 absolute value of x, and that 1/2 stretches it out and makes it wider. So if a is bigger than 1, it gets narrower. If a is greater than 1, it gets wider. All right, let's go inside the parentheses here and talk about our h. This h moves the function around. It moves it left or right. Right, so this h tells us how many spaces to move it left or right. A negative h, or a minus h, moves our function to the right, and a plus h moves it to the left. Think of these as being opposite, all right? So this is f of x equals square root of x, our parent function. And then for this one, notice it's been moved to the left 2 spaces to -2. This is f of x equals the square root of x plus 2. So this plus 2 inside of the square root symbol moves us to the left. This one is f of x equals square root of x minus 3. The minus inside of the square root symbol moves the function to 3 spaces to the right. So inside the parentheses, this minus h moves you left and right. Negative moves you to the right, positive moves you to the left. And finally, the k also moves our function, and it moves our function up or down. If this is a minus k, then our function is going to move down. If it's a plus k, then our function moves up. So here I have, f of x equals the log of x, logarithmic function. This one is moved down, and it's moved down 2 spaces. So this is f of x equals the log of x minus 2. This function over here has been moved up 1 space, so this is log of x plus 1. So you can see how this works. This number on the outside, if it's a negative, it moves it down. If it's a positive, it moves the function up. Let's take a look at some examples about how to use transformations to write equations or how to use equations to figure out transformations. So let's look at this function right here. So it says to state the parent function and describe, I don't know why it says describe, describe the transformations shown in this equation. All right, so first off, let's look at parent function. So if I'm looking at this, I'm like, all right, well, I don't see any sort of squared or cubed or absolute value or anything. There's nothing there, so this is just a linear function, f of x. All right, so now let's think about transformations. This 3, we know the 3 stretches the function, so it's going to be stretched by a factor of 3, which is going to make it narrower. Inside the function, I see this minus 4, and I know that subtracting 4 inside is going to make the function move 4 units to the right, and then outside, this plus 2 makes the function move 2 units up. So these are the transformations that happen based on this equation. All right, if we take a look at example 2, example 2 says write a new equation given this parent function and the transformations. So I want to flip this over the x-axis, shift it 8 units down, and then 3 units left. All right, so our new function is going to look like this. So we've got f of x equals flipping it over the x-axis. Flipping it over the x-axis means I want to put a negative out front of it. Okay. Inside my fraction, I want to do my 3 units left. Remember, left and right are always inside the parentheses, or in this case, inside the fraction. So I'm going to have that be 1 over x plus 3. And then to shift 8 units down, outside of my fraction, I'm going to subtract 8. So this is my new equation. F of x equals negative 1 over x plus 3 minus 8. So it looks like this. All right. So now what I want to do, I want to do one more example. So for this one, it says we want to use this parent function and transformations to write an equation for this graph. All right, so let's think about this. Okay, this has a parabola shape to it, so I know that the parent function is f of x equals x squared. So I'm going to use this. For the transformations, all right, it hasn't been flipped, so I don't need to put any negatives. It hasn't been stretched, so I don't need to have a leading coefficient. It has been moved 2 spaces to the left, and it has been moved 1 space up. So our transformations are shifting it 2 units to the left and 1 unit up. So I'm going to use that to write my equation. All right, so don't need to have anything on the outside. Inside my parentheses, 2 units left is represented as, oh, this shouldn't be minus 2. It should be a plus 2. Okay, so inside my parentheses, moving to the left, is an x plus 2 squared, because this is our parent function, and then plus 1, because this is being shifted 1 unit up. So that's all we need to do to write our equation, is just look at this, recognize the parent function, and recognize the transformation, and use those to write the equation. The final part of this video, we're going to talk about how to graph a function. So we're just going to use 4 steps, and we're going to be using a graphing calculator. So the first thing we're going to do is we're just going to put this into the graphing calculator. We're going to use the table function to find 4 or 5 points to use. We're going to plot those points, and then we're going to draw the graph. Now, I'm not going to be showing you the graphing calculator for this video. We'll talk about that in class, but I am going to show you the general process. So what I would do is I would start by taking my function here and just putting this part of the function into the graphing calculator, and then going to the table. And when I do that, I could get 4 points, or 5 points, and here are 5 points I could get for this function, 2 times absolute value of x minus 5 plus 1. So I've got 5, 1, 4, 3, 3, 5, 6, 3, and 7, 5. And I've plotted those 5 points here. So here's 5, 1, here's 4, 3, here's 3, 5, here's 6, 3, here's 7, 5. And then I just need to draw in my graph. Because this is an absolute value, I know it's going to have that V shape. So there's my absolute value graph. All right, for another example, I've got negative 2 times the absolute value, or times x plus 2 squared minus 4. So negative x plus 2 squared minus 4. once again, I would just put this part of it into my graphing calculator and get some points out. So here are 5 points. I've got -2, -4, -1, -5, and 0, -8, -3, -5, and -4, -8. And because it's a quadratic, I know it has that U parabola shape, so I would just draw that in, and there's my function. So it's pretty simple to graph a function. Use your graphing calculator, find some points, plot those points, and then draw in your line.